In this video, we'll be seeing about the basic circuit components. The first component is resistance. Resistance, it is a passive component and it is a two-terminal component and it opposes the flow of current. Okay, and there will be a voltage drop across the resistance, and here we can use Ohm's law in order to find out the value of resistance, and we will use some proportional relationship here. So we can define resistance as that property of the material by which it opposes the flow of current through it, and the resistance is denoted by capital R. Also, the resistance of any resistor, it will depend upon the length, that is L. Okay, it will depend upon the material and it will depend upon the length of the material in meters. Then you have A, which is nothing but the cross sectional area in square meters, and you have rho, that is the resistivity in ohm meters, and the unit of resistance is ohm. We measure the resistance in ohms. Here the voltage which is developed across the resistor, it will be proportional to the current flowing through it, and we can remove the proportionality sign and take R as the proportionality constant and write it as V is equal to I into R. Now we can define 1 ohm as that resistance of the circuit if it develops 0.24 calories of heat when 1 ampere of current flows through the circuit for 1 second. So here the flow of current should be how much? It should be 1 ampere. Okay, 1 ampere of current flows through the circuit, and it should generate how much heat? It should generate 0.24 calories of heat, and that must be for 1 second. And the measure of the resistance is nothing but that is, the resistance is measured in ohms. Unit of measurement of the resistance is ohms. You can also define the unit ohm as that which allows 1 ampere of current to flow through it when 1 volt voltage is impressed on it. So you can write any of one definition, either this or this. So the relationship between the voltage and the current, it is given by what? It is given by Ohm's law. We get V is equal to I into R by using the Ohm's law. So you can find out the value of the resistance as R is equal to V by I. Next is the inductance. So here inductance, it is an element which stores the energy in the form of electromagnetic field. Okay, so inductance is what? It is an element which stores the energy in the form of electromagnetic field, and it is denoted by capital L, and it is measured in what? Henries. So H is nothing but Henries, where you measure the inductance. Like for resistance you are using ohms, here the measure of unit is Henries. Now here you will be having V of t. Okay, this V of t is time varying voltage and I of t is time varying current. So here for an inductance, the voltage across the inductance, it is proportional to the rate of change of current through it. So you can take the constant of proportionality as inductance. Okay, and you can write this as V of t is equal to L into di of t by dt. Okay, so this was about the inductance. The factors which influence the inductance are the geometry of the inductance, that is, which consists of the number of turns in the inductor, then the coil diameter and the length of the inductor, and also it depends upon the permeability of the material which is being used. Next element is the capacitor. Okay, so here capacitor, it is an element which will store the energy in the form of electrostatic field. Inductor also stores the energy, but it stores the energy in the form of electromagnetic field, whereas this will store the energy in electrostatic field. Now here this capacitance, it is made up of two components, that is the two conductive plates and one dielectric material in between them, and the measure of unit for the capacitance is farads, which is denoted by capital F, and this capacitance, it depends upon the area of the plate, that is the conductive plate which are using, and the distance between these two plates and the permittivity of the dielectric material which is being used. So here you can write for conductance as the current which is flowing through the capacitor. It is proportional to the rate of change of voltage, and so you can take the proportionality constant as C, and you can write it as I of t is equal to C into dV of t by dt. And also you can find out the value of voltage from this equation as 1 by C integration minus infinity to infinity I of t dt. Okay, so this was about the basic circuit components.